Now let's add quadratic features. It means that we're squaring. We're going to add on a new column, squares the variable, to our height data. Polyfit equals polynomial features degree false. I'm not going to fit transform it yet. Instead, what I'm going to do is I'm going to go ahead and create a placeholder. What a polynomial model looks like is a multilinear model on polynomial feature, on the polynomial. So I'm creating a linear regression object, and I'm actually going to combine these into a pipeline. A pipeline is a really useful way of combining multiple steps of a data process. I'm going to say from pipeline and make pipeline, and now quad pipeline equals make pipeline polyfit qm. So what does the pipeline do? First step of it transforms the data so that the data works well with a polynomial, and then the second step actually fits the polynomial to the, I can do quadreg time data height data dot excuse me. So I see I have two coefficients. That's because I have two variables as far as this model is concerned. I have the x variable and I have the x squared. And if you look way back at our first example here, when we applied polynomial features, first column was the x variable and the second column was the x squared variable. So this tells me that the coefficient on x is roughly 30.004, and I've written this down here. And the coefficient on x squared is roughly negative 1.000, and I've written that down here. And then if I do qm dot intercept, I see that the intercept of this model is 9.992, and I've written that down here. So we can see that the quadratic regression that we've done predicts that height can be predicted from time by this polynomial formula.